All right, in our previous videos, we solved systems of equations by graphing, by substitution, and we got to elimination, but we just did one or two problems with elimination. So I'm going to continue with solving systems of equations using elimination in this video. So here's an example of a system of equations, and I want to use elimination because first of all, both of these equations would be challenging to some level to solve for x or y. We would have, well, we have a lot of fractions already, but I'm going to go through and clear the fractions in here in just a minute. But the reason you want to use elimination is because you have your x's lined up, your y's are lined up, and your constants are lined up. And so it can be really helpful. Like, this method is probably best when that's the situation. All right, so we have equation 1, we have equation 2, and we're trying to find that one xy ordered pair, if there's just one solution, that is. And we have fractions. So I'm going to begin by clearing those fractions. So look at your least common denominator of the fractions here. We got a 5 in the denominator, we got a 4 in the denominator. My least common denominator would just be 20, 5 times 4. So I'm going to multiply each of these terms by 20. So if I do that, 20 times, I'm going to make 20 over 1 because I'm multiplying it by 3 over 5, so that it lines up. And then I'm going to multiply 3/4 times 20 over 1 again. And then I have to also multiply the 3 over here by 20. I have to multiply every term by 20. All right, and the reason we do that is now if you look at this right here, 20 times 3 is 60, 60 divided by 5. We could figure it out that way, or we can simplify it first. 5 goes into itself once and into 24 times, and then multiply across. You got 4 times 3, which is 12, over 1 times 1. I don't need to write it over 1. It's just 12x. Plus this, if I simplify that first, I get a 4 goes into itself once and into 25 times. So 5 times 3 across the top gives me 15 over 1. So that's 15y. And then we get 20 times 3, which is 60. All right, so the second equation is also least common denominator is 20. So I'm going to multiply every term by 20. Why don't you do that? And then, so this is equation 1 rewritten. And then write that equation 2 right below it, and we'll come back. So pause the video and do it on your own. Okay, I got 8x plus 5y equals 0. Here's my work over here. I multiplied 20 over 1 times 2 over 5. The 5 becomes, I can simplify it into, 5 goes into itself once and into 24 times. Multiply across, get 8x over 1, which we don't need to write over 1. And then 20 times 1/4, or a fourth of 20. You can also think of it just like that. What's a fourth of 20? It would be 5y. And then 0 times anything is going to be 0. So then now I have no fractions to worry about. I'm going to erase some of this here so I can move this up a little bit and have a little more room to work. Oh man, it's all here. Hold on. Okay, so we have 12x plus 15y equals 60. 8x plus 5y equals 0. Okay, in the previous video we had a negative x and an x and they eliminated each other when we added. Here that's not going to be the case because the coefficients in front of x are 12 and 8 and in front of y is 15 and 5. They're not exactly the opposite and therefore they will not eliminate. Neither variable will be eliminated if I try to add right now. Here's what you need to do. You look at the numbers 12 and 8 and 15 and 5, the coefficients of x and y, and think about how you could make them exactly the opposite. What one would be the easiest? And if you look at 15 and 5, I can multiply 5 times negative 3 to get a negative 15y right here. So what I want to do is I want to multiply everything, because you can't just do it to one term, you got to do it to all the terms. I'm going to multiply equation 2 by negative 3, every single term by negative 3. So that becomes 8 times negative 3 is negative 24x. 5 times negative 3 is negative 15y, which is why we're doing this. And you'll see if I just rewrite, and then negative 3 times 0 is 0. And rewriting number 1 right above it, you get 12x plus 15y equals 60, same equation as we started, well, after eliminating the fractions. But now look at, you have a 15y and you have a negative 15y. So now when I add, I'm going to get the y to be eliminated, which is why it's called the elimination method. So I have 12x, I'm going to add this column, the x column, 12, and negative 24. Don't forget your negatives, be really careful with that. 12 minus 24 is negative 12x. 15y minus 15y adds to 0, so that's plus 0, which you don't need to write. And then 60 plus 0 is 60. So then solving negative 12x equals 60 for x, we're going to divide by negative 12. And you get x on this side, and 60 divided by a positive 60 divided by a negative 12 is negative 5. And you can plug that negative 5 back into the original equations, or you can plug it into the equations where we eliminated the fractions. We cleared the fractions. I'm going to use the ones where we cleared the fractions just a little bit easier. And I'm going to put negative 5 in for y. And you can pick equation 1 or equation 2. And I'm going to use equation 2 just because the numbers are a little bit smaller and a little easier to work with. So I'm going to plug in x equals negative 5 and solve for y. So 8 times negative 5 plus 5y equals 0. That's negative 40 plus 5y equals 0. Add 40 to both sides. This side will be 5y, and adding 40 to 0 equals 40. Divide by 5, and we get our y value is 40 divided by 5, which is 8. So our solution to the system is negative 5, 8. And then we should be in the habit of checking our answers. So you know what, because it's got all these fractions, I'm going to do that with you guys right now. Oh, hold on a second. I'm going to clone this page so that I can get rid of all this stuff. So I'm going to eliminate all of these things. So I'm going to check it in the original. I could have checked it in the equations where I cleared the fractions, but I'm going to check it in the original because what if I made a mistake when I was clearing the fractions? So let's test it in 1. We're going to check to see if negative 5, 8 will give me, when I put in negative 5 for x and 8 for y, will it give me 3? So you get 3/5 times negative 5 over 1 plus 3/4, and I'm making it negative 5 over 1 because it's being multiplied by a fraction. And then 3/4 times 8 over 1, does that equal 3? Well, negative 5 over 5, that's a negative 1. So negative 1 times 3 is a negative 3. And then the 4 and the 8, I can simplify to 1 and 2. So that's 6. 3 times 2 is 6 over 1 times 1 is 1. Does that equal 3? And yes, it does. And then testing it in the second one, I have 2/5 times negative 5 over 1 plus 1/4 times 8 over 1. Does that equal 0? This 5 and that negative 5 simplifies to negative 1, so this is negative 2 plus 4 goes into itself once and into 8 twice, so it's 1 times 2. 2, negative 2 plus 2 does equal 0. Okay, so write this system down. For this system, it would be pretty easy to solve for x, the top equation, solve this first equation for x. However, I'm not going to do that because the x's are lined up, the y's are lined up, and the constants are lined up. So for me, I'd prefer to use elimination. Now I have a 1x and a 2x. I have a 3y and a negative 5y. It's going to be easier to get my x's to be exactly the opposite. I need this top x value to be a negative 2x. So I'm going to multiply across the whole thing by negative 2. So then I get x times negative 2 is negative 2x plus 3 times negative 2 is negative 6 or minus 6y. And then negative 13 times the negative 2 is positive 26. And I'm just going to rewrite equation 2 underneath here because I don't need to do anything to the second equation. So adding this adds to 0, and then this is minus 11y or negative 11y, and then this is going to be 33. I don't need that 0 here, but I do need to divide by negative 11 to get y by itself, and I get y equals negative 3. Okay, so you plug in y back in, I would suggest, into the top equation and figure out what x is. So the solution is you should have gotten negative 4 for x, and you get negative 4, negative 3 is the solution. Okay, this next one, I want you to pause the video and do this one on your own. Think about which variable would be easier to eliminate. I'm going to give you a hint. It's going to be this one. What would you have to multiply this second equation by so that the x's will drop out? All right, so I kept the first equation as is, and I multiplied equation 2 by a 5, and then that makes this a negative 5x plus 10y, because I have to multiply everything by 5, and equals 35. Add down the x's, drop out, which is why it's called the elimination method. We eliminated x. Negative 5y plus 10y is 5y, and on this side, the constants, negative 20 plus 35 is positive 15. Divide both sides by 5, and you get y is 3. And then I put 3 back into, I used equation 1. You can use either one. And I solved for x, and I got x is negative 1. Then you're going to get some questions where it says to solve by a method of your choice, and you can use either one, elimination or substitution. And you could do either one for this type of problem because the top equation 1 is easy to solve for x. Equation 2 is easy to solve for y, and you could do substitution if you prefer it. Or you could drop out one of the variables. I could multiply this by 5, and then this would become a 5x, and negative 25y equals 40, and then your x's would drop out, and then you could solve for y and then plug that back in to get x. So you're going to have to pick which way is easiest. This one I would probably use substitution because this is already solved for x. So then you can put this in place of x in equation 1, solve for y, and we've done a few problems like that, so hopefully you got that down. Okay, this one, again, I would use substitution. You can just put 1/2 x in for y. Let's see, and here's one with fractions. I would start by clearing the fractions. So multiply this by 6 and multiply this by the least common denominator of 3, 4, and 6 is going to be 12. So go ahead and multiply to clear the fractions on both of these, and then we'll finish the problem together. You do the clearing the fractions on your own. So you should, if you multiply by 6, you get 3x minus 3y equals 1 for equation 1. And equation 2, multiplying everything by 12, you get 4x minus 3y equals 2. And then, since if you look at the result, I have y values that are not exactly the opposite, they're the same. So what I want to do is multiply either one of these by a negative 1 so that one of them is positive and one is negative. So I'm gonna put it up here. 3x minus 3y equals 1. And then the bottom, if I multiply by a negative, it's going to change the sign on everything. So it's going to be negative 4x plus 3y. Now my y's will drop out, equals negative 2. Adding, I'm going to get 1x, the y's drop out, and I get equals negative 1. So you get your x value, and then you're going to plug it back in to find y. You could do either the original problems, or you can use one of these. I'm going to use equation 2 here and put negative 1 in for this x to solve for y. So minus 3y equals 2. Get negative 4 minus 3y equals 2. Add the 4, and I'm going to get negative 3y equals 6. Divide by negative 3, divide by negative 3, and y equals negative 2. So the solution is negative 1, negative 2. So you got to choose wisely which one looks easier. And I'm going to do a word problem. You'll have one word problem in this homework assignment, and I'll do that in another video.